first speaker, Bart, who will be discussing Flatpak apps without Flatpak-builder. Take it away, Bart.
Thank you. And hello, everyone. My name is Bartłomiej Piotrowski, or just Bart. For almost 10 years, I have been maintaining packages for Arch Linux as a developer. These days, I'm an admin/maintainer of FlatHub, a build and distribution platform for Flashbacks. Today, I'm going to talk about building Flatpak packages using Flatpak directly. This is a somewhat unusual way that is also not documented perfectly, but is useful in some cases like integrating Flatpak support into build tools or pipelines. Before we start, let's have a quick refresher what Flatpak actually is. So there is something ironic about saying that on a packaging conference, but a sales pitch for Flatpak would be built once, run everywhere, with some obligatory caveats. In simple, not simple words, it may be considered a sandboxed CH root on steroids. Applications run on shared portable runtimes, which provide core libraries and tools like GCC and OpenSSL, meaning that application maintainers don't need to be worried about security updates for core stuff. Files are deduplicated thanks to OS3, which is not far from Git for binaries. Upgrades are differential by default, so only changed files are downloaded during update. It's Linux desktop oriented, but can be used for CLI tools as well. It is not tied to single vendor or store, meaning anyone can host their own repository, publicly or internally. Applications can define static permissions like direct file system access for backwards compatibility, or use various portals that require explicit user consent. The general idea is to detach dev packages like video players or video conference software from development of a distribution, meaning distro maintainers can focus on building a stable foundation to run software on. And as you can probably guess, Flatpak-builder is the best tool for building Flatpak packages. It takes JSON or YAML files as the input, ensures runtimes and files are downloaded, then executes build steps with some simple caching. This is how an example Flatpak-builder manifest looks like. There is not much magic here: an ID definition, specification of runtime and SDK, default command to execute, and an array describing modules to build. If I execute this manifest with Flatpak-builder, we will have a working GNU Hello example, which is probably not very useful, but good for demonstration purposes. So far, so good, but nothing is ever easy. In order for sandboxing to work, Flatpak uses various technologies that are problematic to use in the usual locked-down CI systems. Fuse, user namespaces, seccomp profile, unless CI worker is already privileged, meaning it's less secure, Flatpak and tools Flatpak-builder are unlikely to work at all. From another perspective, it also doesn't make sense to build an application twice if you already have an established and well-maintained build pipeline that produces portable builds. It's a waste of both engineering time and CI time. How to build a portable Elf binaries is a broad subject we don't really have time to discuss in the scope of this talk. For presentation purposes, I have built NCTU, a disk usage analyzer with terminal interface. As it's a very simple program, I could get away by building it on an older Linux distribution like Ubuntu 18.04, as glibc is only forward compatible, meaning that if we take Arch Linux or Fedora and build something on it, it won't work on older versions of any Linux distribution. After successful build, which is nothing unusual, just running configure and make install, we can inspect shared libraries required by the NCTU binary with LDD. What really matters on this list is libencurses.so and libtinfo.so. So let's take these files outside the build environment and see how to make it into a Flatpak package. First of all, we need to create a fake build directory where we are going to place NCTU and libraries in a minute. But before we do that, we also need to create the metadata file. It instructs Flatpak which runtime to use and also defines application ID and the entry point command, very much like the initial section of Flatpak-builder manifest I have shown a few slides before. This also corresponds to Flatpak build init command, which for various reasons doesn't work in some environments. As it's a simple ini file, we can simply use a text editor here instead of Flatpak command. When we have the build directory ready, we need to create the files directory. And this is the actual package content. It doesn't need to follow any specific standard like VHS, but by default, the lib directory is added to the default path of the loader, and the bin directory is in the default command path. So that's where I place the files in the binary. We also need to create the export directory, as it's required by Flatpak, even though we won't be using for anything here. In practice, that's where it would put desktop launcher and appdata file that are later used on the host file system to actually show your application in the usual Linux desktop environment. For demonstration purposes, I have also placed some files under share/local and share/runtime directories. By default, Flatpak-builder will detect these and put them into a separate extension. During installation, Flatpak will download a subset of files required by locally configured languages. Because we are doing everything manually here, we need to prepare everything ourselves as well. So in order to make this work, we need to define an extension point in the main metadata file. We specify the name of the extension, the place where it will be mounted during Flatpak run. We also tell Flatpak to remove it when the main non-local ID is removed by setting auto-delete to true, and to apply the magic sauce for installing only required languages by setting local substitute to true. Then we need another metadata file that is going to be used for the local extension only. It's very simple, as it only defines the ID and which reference it is extension of. The build finish command will add a section describing static permissions. Disk usage analyzer sounds like something that should have access at least to the home directory. While this can be done with regular text editor, just like we did before, CLI arguments are slightly different from the final form in the metadata file, so it's just easier this way. This also matches arguments that can be passed to Flatpak run or Flatpak override. Finally, we can consider the build directory ready for further processing. The build export command will create OSTree commits and references in the repo directory based on the metadata files. As we are interested in splitting our fake local extension, we need to be explicit which files should be included or excluded. In the first command, we exclude the local files, as we don't want to ship them at all with the application itself. And in the second command, we are specifying the metadata, the separate metadata file for local, and files where local stuff is included. And that's it. That will create another commit, which will include only the local files. The resulting repo directory can be either uploaded or to FlatManager instance, which is a repo management service for Flatpak, or can be used to create a single file bundle. I will talk about this in a minute. So, as NCDU is a simple case, I need to admit that nothing of this is particularly impressive. A real-life example is Mozilla Firefox, which uses Flatpak as part of its CI. New Firefox releases are pushed to FlatHub at the same time when all other platforms like Windows are published. The first half of the script is some boilerplate related to fetching build artifacts, but the rest is in line with what I have shown you before. Let me open the script, and that will make things easier to explain. So this is the set boilerplate, but the actual Flatpak stuff begins somewhere here at the 76th line, where the script adds FlatHub remote to fetch the base app, which ships some of the libraries that are not part of the usual build artifacts. And then it just creates the metadata file with one exception of FFmpeg full, which is for hardware accelerated decoding. Then creates another metadata file for the local, and then just does the usual file shuffling. So that installs the Firefox itself, it installs the app data file, desktop file, icons, runs a few other commands that are not necessarily interesting in this context, creates symlinks for the language packs, and then runs the build finish to create the permissions section in the metadata file, and then runs build export twice for the app itself and the local file. Let me go back to slides. So there are tools that already integrate Flatpak. BuildStream is used by FreeDesktop SDK and GNOME to build respective Flatpak runtimes. It can be also used to package regular software, not just runtimes, and output set application as an OSTree repo. If you would like to learn more about this, Sam Tersfield will be talking about both BuildStream and FreeDesktop SDK tomorrow, 5 p.m. UTC. Flatpak module tools is used by Fedora to create its Flatpak repository and packages. As far as I understand the RPM build process, it takes the usual RPM spec but sets a different prefix, which is /app in our example, and then uses OCI format, usually used for Docker images instead of OSTree, to distribute software for Flatpak. And just to prove you that this is not some GPT-3 generated mambo jumbo, let's poke around the files I prepared during working on this presentation. Let me open the terminal. So here we are in the demo directory. you can see the directory tree here. So we have an export directory, which is completely empty in this case. We have the NCDU binary, 2 shared libraries for lib and curses and libtinfo, fake symlink that is not currently resolving properly, and 2 locals, DE and EN, for German and English respectively, and 2 metadata files. So I'm going to run build exports twice. If I only manage to type things correctly. So here I'm creating the auth3 commit for the application itself. I'm excluding share/runtime. And here I can see that auth3 properly created a commit for me and has written 580 kilobytes of data. And I'm going to run a var command for the local. So I'm specifying the metadata file, specifying the files to include, and the rest of parameters stays the same. And here I'm writing on 109 bytes because this is just a simple example and not actual languages for NCDU. So now, when I have these commits supposedly created, I can actually list them in the repository, as each Flatpak repo is just generic auth3 repository. I'm using auth3 commands instead. And I can also list the contents of each reference. So here's the content of the NCDU reference, which holds the application itself. I can also list the contents of the local extension, which just consists of metadata file and these 2 languages. Just to prove you that it actually works, I can do 2 things. I can build a bundle, which is something you can later take and upload to GitHub releases or anywhere else. So this command, build bundle, repo, file name, and reference name, will create a single file bundle that can be later shared. And I can just install it by pointing Flatpak directly to this file. It will do its magic, tell me that it has nothing to download because, of course, it's already on my disk. And after installation is complete, I can enter the sandbox with my application inside app. Or I can just launch this directly because it doesn't really matter. So here is the local directory and functional NCDU. I can also add the repo directory as Flatpak remote for local testing. So this has added the NCDU repo as a remote, and I can install from it. And as you can see, it shows local extension this time, but it says partial. So it's not going to download entire language packs that are available in the local, but only the English one. And when I enter it this time, not run, but enter. So I need to specify the command to run inside the sandbox. I can again navigate to app, and here go to share runtime local. And you can see that only English language, if we can call it this way, is visible within the app. And it has very complicated content of na. We can also verify that NCDU is actually using NCDU for the libraries we are shipping within the Flatpak. So you can see here that it uses libraries from /app/lib. While if we poke around inside the sandbox, if I only find the proper location, not here, we can see that only Soname version 6 is available inside the sandbox. So I know Flatpak isn't the most transparent packaging format in the world, but I hope this presentation demystifies how it works a little bit. if you would like to talk about integrating Flatpak with your build tool, or maybe publish your application on FlatHub, do not hesitate to poke me somewhere on Matrix, Twitter, or anywhere else. Yeah, I'm a little faster than I expected, but that's it. And thank you very much for coming.
Thank you very much. Let's see. So I have a question. So who are, like, to the extent that you know, who are the majority users of your system with Flatpak?
So the usual target for Flatpak is Linux desktop. And so it means that people who are usually interested in Flatpak are users of closed source software, because Flatpak offers at least some of sandboxing. So if you are unsure that Spotify will only play the music on your laptop, that's the usual way of installing Spotify on Linux, because this way you are sure it's not going to look through your files and so on and so on. Flatpak can be, of course, used for any desktop applications. And yeah, of course, the long-term goal is world domination.
I suspect that that might be a theme at this particular conference.
Yeah, definitely. I mean, that's why I said it's actually funny that I'm going to say it's supposed to be, built once and you can run it everywhere. Because, yeah, I can imagine that everyone is going to say the same about their favorite packaging tool.
I guess that's the benefit of being the first talk, is that you get to be the one of the first ones to make that claim.
Yeah, of course. I mean, Flatpak is the best. Don't watch any other talks on this conference. You can go back to your lives now.
As session chair for this, I must implore the audience to ignore him. But let's see. Are there any questions from the room? Normally, I could look at people out in an audience and pick people out. Yes, we have one from YouTube. How well does Flatpak work for CLI utilities?
Oh, that's fancy. It actually shows the question. It's really amazing. So I can say it works. It's not really perfect. So as you can see on the example with NCDU, I will get back here. There is no magical NCDU command. So if I show where is output, it's actually NCDU I have installed on the system directly. So one of the drawbacks is that you actually need to create your own aliases for commands. There is, of course, some delay caused by all the sandboxing magic. So it's probably not the best idea to use it for editor if you are launching multiple terminals and running Vim or Emacs in each of them. But in general, even if it's not the main focus of Flatpak, it's serviceable.
Thank you. Are there other questions from the room? We have a few more minutes, maybe room for one more question. I think everyone's somewhat blown away by the, by this. So there's a little,
I hope so.
just sheer stun. So I guess I'll ask one last one, hopefully be pretty quick. Given the next talk, which I'll tease a little bit as being about licensing and license compliance, what is the license on Flatpak?
For Flatpak itself, I'm not really sure. I think it's some permissive license, but for the actual contents of the package, I think it's probably what the next talk is about. So it's probably about the Docker and licensing. So yeah, that's very fair question. You of course cannot put a single license on a huge bundle of various libraries. So if your company lawyers are chasing you, then you probably need to write some really fancy script that will somehow scrap all the licenses from the running sandbox, so you have a proper list of everything to use.
We've actually got one more question coming from the Element room. Is there any work towards automatic alias creation?
Yeah, there is. I mean, it's not part of Flatpak itself, but you can find a simple shell script on my blog because I'm using it myself for easier launching of things like, I don't know, gedit or GIMP, because despite the fact I use GNOME, I'm spending most of my time in the terminal. And what Flatpak offers by default is that it creates, well, it's not exactly convenient, I need to say. It creates something called export/bin, and here it uses the reverse DNS notation. So I can just launch the org.flatpak.ncdu, and it's gonna index all the junk I have in my home directory, which is probably not very interesting. So it is there, but there's no simple way of making sure that there are no conflicts between various packages providing the same binary. So you need to use the reverse DNS notation, otherwise things can, well, could, not can, override each other.
Okay. Well, let's give Bart a wonderful hand, since his talk was so stunning. Thank you very much.
Thank you very much. Thank you.